Actually not able to get my.
Why is the board staticky like that?
The wire does that. It's actually staticky every day. It's always like that.
Really?
Yeah, some days it's just hard to notice. Okay, so in this system, are any of the variables opposites?
No.
No, I have a 3 and a 4. I have a 2, a positive 2, and a positive 3. So none of them are opposites, but we can take it one step further here.
You can add to them.
Example. So how is this different? This would be the example that you can write down. How is this system different than the other ones that we saw yesterday?
Because the systems that we had yesterday were the ones that you can multiply by a number and then get a system out, like an X or a Y.
And when we were doing this yesterday, how many of the equations were we doing something to?
One equation.
Yeah, just one of them. Okay, so if you notice these coefficients, could I multiply 4 by something, by a whole number to get 3?
Negative. No.
Could I multiply 4 by a whole number to get negative 3? To get negative 3.
No.
Right. Could I multiply 3 by a whole number to get 4? No. Could I multiply 2 by a whole number to get 3?
No.
Could I multiply 3 by a whole number to get 2?
No.
No, so the problem here is that I can't just multiply one of the equations to get an opposite of the other. So if I can't multiply one of them, what could I do?
Multiply the
I could multiply
Both?
I could multiply both. Yeah. But think about what I would have to multiply by.
the x by
Think about, because I know some of you are writing down the example. Think about what can I multiply both equations by so that these two numbers become opposites. If you didn't want to get rid of the x, think about the y. What could I multiply both equations by so that these two numbers become opposites? Okay. We're going to go over this example. So we can multiply both. Okay? You don't have to necessarily write that sentence down. This would be our next level of difficulty in terms of eliminating a variable. If I wanted to eliminate x, what would you multiply the equation by?
I would multiply the top one by 4 and the bottom one by -3.
Why did Laura multiply the bottom equation by -3?
because you're trying to get the opposite of 12x.
Exactly. I'm not just trying to make both of those x's become 12. One of them would need to become a -12. I need to create an opposite. If I multiplied everything in here, I would end up with 12x plus 8y equals 4. This other equation would be -12x minus 9y equals 6. Now looking at the equations, I did do something to both, but now do I have opposites? Yeah, so which variable eliminates? My x's eliminate when I combine. So I'd be left here with -y equals 10. And if I wanted to solve for y, what do I get?
Y equals -10.
Now, did I need to multiply the top equation by 4 and the bottom equation by -3? Or is there something else I could have done to eliminate the x? Could I have done something else?
To eliminate the Y.
Well, I could eliminate, we're going to do the y next, but there's actually something else you could have done here to eliminate x. Did I need to multiply the top by a +4 and the bottom by a -3?
No.
What else could I have done?
-4.
Yeah, I could have multiplied the top equation by -4 and the bottom equation by +3. I still would have generated an opposite in my x's coefficient. And the reason I like to show you all of the options is because when we're going through examples, especially if you're working alongside someone, you may choose to eliminate a different variable or choose a different method. Don't think that you're wrong, because you would still end up with the same answer. Right? Before we substitute back in and find the other variable, we're going to actually try the same problem again to eliminate y. What could I do to eliminate my y?
You could multiply the top equation by -3 and the bottom one by 2.
Would this generate an opposite in my y value?
Yes.
Yeah. this would become negative 9x minus 6y equals negative 3. And this would become 8x plus 6y equals negative 4. If I combine, do my y's eliminate? Yeah, they eliminate, and I'm left with negative x equals negative 7. So what's x? X would be positive 7. And if that was the way you did this problem and you wanted to eliminate the y value, from here you could substitute 7 back in to find y. We already found the y value on the previous slide, so you don't have to go through that finishing touch of solving this system, because what we're talking about today are just doing something, manipulating both equations. Did I have to multiply my top equation by negative 3 and my bottom equation by positive 2 to eliminate the y? What else could I have done?
Switch around.
Positive 3 and a negative 2.
Yeah, I could have multiplied by a positive 3 and a negative 2. That would have been another option. So as you're looking at these systems, think about which variable would it be easiest for you to eliminate, because then you can go through any process you need to in order to get those opposites and eliminate that variable. You're going to try one like this. I tried this one. It's like about 5 minutes. I'm actually going to pause the video. It's super short, but I just wanted to make sure we saw the example of manipulating two equations. Try this example. You determine which variable you want to eliminate.